Good day, today we're going to explain on PVT behavior of pure and binary fluids. The PVT behavior of pure fluids, there are two types of PVT relation, which is substance that expand on freezing and contracts on freezing. Three types of projection, PT diagram, PV diagram and TV diagram. For PVT behavior of binary fluids, two chemical species and two phases involved. The PXY diagram and TXY diagram are drawn.
The PT diagram consists of three lines, which is the fusion curve line, the vaporization curve line, and the sublimation curve line. The fusion curve line is further divided into two types, depending on whether the substance contracts upon freezing or expands upon freezing. Phase change between the solid and liquid occurs through the fusion curve line, while phase change between liquid and gas occurs through the vaporization curve line, while phase change between solid and gas occurs through the sublimation curve line. The triple point is a point where solid, liquid and gaseous phases all exist in equilibrium. The critical point is a point where the liquid and gaseous phase cannot be distinguished from each other, and past this point, no phase boundaries exist.
Pure PV diagram for pure substance. First, we draw the y-axis, pressure, and then x-axis, specific volume. Then we draw saturated liquid line to the saturated vapor line connected through the critical point. Then we draw isotherm line, which is the temperature is kept constant from top right to the left bottom. From there, from the left side is compressed liquid region, and then from the right side is superheated vapor region, and in the middle of those two is saturated vapor liquid mixture region.
TV diagram for pure substances. For TV diagram for pure substances, there are four main important things that you should know on how to draw the graph. Firstly is the critical point, compressed liquid region, superheated vapor region, and the saturated liquid vapor region. Definition of the critical point is where saturated liquid and the saturated vapor states are identical. And definition for the compressed liquid region is where the liquid will not about to evaporate, and the superheated vapor region is defined as the vapor will not about to condense, and the saturated liquid means it's about to vaporize, and the saturated vapor means that it will about to condense.
Now I'm going to explain on PXY diagram for binary fluids. X1, Y1 and pressure axis are being drawn in the diagram. In this diagram, it shows two species which are light and heavy species. There are two equilibrium lines plotted in diagram. Three states are being shown, which are subcooled liquid, two-phase and also superheated vapor states. The upper equilibrium line is known as saturated liquid and bottom line is known as saturated vapor. For example, at the X1 composition of 0.5, at point A, the state of subcooled liquid mixture is shown. At point B, saturated liquid, which is known as bubble point, is shown, and a straight line is drawn along x-axis, and vapor bubble in equilibrium with B is shown. At point C, saturated vapor state, which is known as dew point, is being drawn, and the straight line along the axis from between B and B prime is known as tying line, and at point D, the state of superheated vapor is shown.
Looking at 50% composition of species 1 and species 2, when we increase our temperature till the first line, which is the bubble point line, then we'll have our first bubble formed at this temperature. The opposite line is called the dew point line, where the first liquid droplet is formed, which is going from vapor as we decrease the temperature. From the saturated liquid line, we draw a tie line to the vapor line to determine the composition of first droplet of vapor. In this case, enriched in water with a mole fraction of 0.9. As we increase the temperature, the composition of water in vapor phase decreases. When we move up to VLE part, which is also known as vapor-liquid equilibrium, the vapor will have a composition of 0.75. When we increase to the saturated vapor line, we have all vapor at its dew point. The composition of water at this point is 0.1.